Welcome to my channel, everybody. And this is the second class for the ellipse. So here's the 1, 2, 3, 4, 5 5-year problem here. Okay, and for this question, there are ascending angle are alpha, beta, gamma, delta. Okay, then show that. Okay, tan alpha by 2, tan beta by 2, tan gamma by 2, tan delta by 2. ठीक है. Okay, and these are the 5 problem of ascending. Okay, and now see, for in book of ascending, for the problem of marks 4 and question number 3 and part 9, and here I have given that the major axis is x-axis and minor axis is y-axis. Okay, now find the equation of the ellipse whose eccentricity is that is equal to 1 by root 2, and sum of square of the major axis and minor axis is 24. So it is given that the major axis and minor axis are x-axis and y-axis respectively. Now we have to show the equation. Now find the equation. So let us assume the equation be ellipse are, this is 3, okay, and 3 part 9, and this is y square by b square also equal to 1. Okay, now so here is a greater than b are given, and now e is equal to 1 by root 2 here. Okay, and the square of major axis, that is 2a square, and square of minor axis, that is 2b square, is given that the 24. And now from b square equal to, we can write a square into 1 minus a square. So b square equal to a square into 1 minus e square. E square means 1 by 4 here. So now b square is equal to 3 by 4 a square. So a square plus b square, and 4 6 are 24. Okay, 6. So 4 are cancelled on the both sides. So put the value of a square on this. So we can easily find the value of a square. So b square is 3 by 4 a square equal to 6. So that is 7a square by 4 equal to 6, that is 24. So a square is equal to 24 by 7. Okay, now b square is equal to, this is 3 by 4 a square, or 3 by 4 into a square means that is 24 by 7, 6, 18 by 7. Okay, therefore the equation of the ellipse is x square by a square. A square means the value here is 24 by 7, and y square by b square, that is 18 by 7, and that is equal to 1. Okay, so this is the question number 1 for this video. And now the question number 7. See, all of you given the points here. Eccentricity is given that e is equal to half, and focus is 2, 0, and the equation of directrix is x is equal to 8, and also same the condition there, and okay. So now we have to use the formula that is P is equal to PM. If you given for this 3 conic section, that is parabola, ellipse, hyperbola. For ellipse and hyperbola, if you given the value of E and the coordinate focus and directrix, and then we can easily use the formula that is PS by PM equal to E. Okay, so this is the drawing, this is the data, that is E is equal to half, and focus is here 2, 0, and directrix is 8. Okay, so see the drawing, that is 2, 0. Okay, and equation of directrix here is x equal to 8. 2, 1, 2, 3, 4 part. Okay, this is 8. This is the x is equal to 8. Okay, if this is the focus, so this is your drawing of the ellipse. So now this is A here, so P is this x comma y, and this is PM. This is perpendicular. Now PS by PM is equal to E. So PS, the distance between the xy to 2 comma 0. This is given here 2 comma 0. Okay, see, this is 2 comma 0. So we can write root over x minus 2 whole square and y minus 0 whole square. Okay, and by PM, that is x minus 8 and is equal to half. Okay, now x minus x square 4x plus 4 plus y square is equal to half into x minus 8. That is 2, this is square, this is square, okay, this is square. And now here is x square, 4x square, 16x, 16, 4y square, x square, 16x, 64. These are cancelled. So this is here 3x square, and this is here 4y square, and 64 minus 16 is equal to 64 minus 16. Okay, then subtract this value, we got the answer of the ellipse. Okay, so this is one of the problem, easiest problem. Okay, now follow the, see carefully. Okay, P is equal to E into PM. You should apply always if you know the eccentricity and focus and equation of directrix. Okay, so now see the second question. Now see the second question, third question. That is, okay, see the third question. X equal to, we have given a into 1 minus t square by 1 plus t square, and y is equal to b into 2t by 1 plus t square. Okay, see that is the variable parameter, and then find the locus of this points. Okay, this is a point, find the locus of the point. So you should always divide by x and squaring both sides, and sum of the squaring of both sides, and we also divide this, and then what do you get there? See here 1 minus t square by 1 plus t square, and 2b, this is 2t, okay, 2t by 1 plus t square, okay, and whole square. Take a LCM, that is 1 plus t square and whole square, and here is 1 minus t square whole square and 4t square. So we can easily simplify this and get here 1. Okay, so this is the equation, this locus is the equation of the ellipse, okay, of this variable point. And now for the 16 number question, and 22 is a very important question in this video. Okay, see, okay, this is the 15 of marks 4. Okay, now 16 to the book of ascending. Okay, see here 16. Okay, the eccentric angle of the 2 points, like here, this is the ellipse. Okay, this is the ellipse. Okay, and there are the 2 eccentric angles. Let us assume this is a P and this is a Q. So that is given that the eccentric angle will be there theta 1 and theta 2. Okay, theta 1 and theta 2. 2 points are theta 1 and theta 2. So we can easily, eccentric angles means the parametric coordinate is of the ellipse be a cos theta comma b sin theta, then theta is called the eccentric angle. Okay, now that type of angle are given, that's theta 1 and theta 2. So we can easily, an equation be here, if we given that, the equation be here x square by a square, so y square by b square. Okay, this is equal to 1. So a cos phi comma, sorry, this is theta 1. Okay, this is theta 1 and theta 2. Okay, b sin theta 1, and another point is they have a cos theta 2 comma b sin theta 2. Okay, now find the equation of the chord PQ. Therefore, the equation of chord PQ is like a straight line. This is the definition of straight line, y minus y1. This is, let us say, this is assume y1 be sine theta 1, and this is equal to y2 minus y1. This is a slope, that is b sine theta 2 minus b sine theta 1 by a cos theta 2 minus a cos theta 1, again x minus x1, this is your x1, a cos theta 1, and we simplify this like y minus b sine theta 1, and take a common b from numerator and a from denominator, so b by a, and then we get sin c minus sin d, and that is 2 cos theta 1 plus theta 2 is here, okay, and also sine of and theta 2 minus theta 1 here, okay, by 2, and see cos here, so 2 sine theta 1 plus theta 2 by 2, sorry, and this is d minus c by 2, take a common minus here, so we can c minus, we can write here theta 2 minus theta 1 by 2 here, and x minus a cos theta 1, and these two factors are cancelled, and now the x by a here, so you write here x by a, so this is by a, so now this is by b, so we can write here, and factor is cos of into, so here is y by b into sine of that, so we can take a divide by y by b here, and multiply by this factor 2 here, okay, 2 are cancelled, okay, sine of theta 1 plus theta 2 by 2 here, okay, and if we multiply this same as if we divide b by b, so that is b are cancelled, okay, now b by b is cancelled, and these are multiplied, so sine theta 1 into sine of theta 1 plus theta 2 by 2 here, okay. Same on the right hand side, same on the right, there is a minus, so divide by a, so minus x by a, and multiply by cos, so this is cos here, okay, cos of theta 1 plus theta 2 by 2, and again see if we multiply divide by a, then we got cos, so this is minus minus plus, so this is cos theta 1, and cos of that, and cos of theta 1 plus theta 2 by 2 here, okay, and take this part on the left hand side, this is cos a, and cos of theta 1 plus theta 2, okay, and from on the right hand side, left hand side, this is b by y, y by b, and sine of and theta 1 plus theta 2 by 2 here, and take this part on the right hand side, then you get cos a cos b plus sin a sin b, so that is cos of a minus b, that is theta 1 minus theta 1 plus theta 2 by 2, and that is equal to cos of and theta 1 minus theta 2 by 2, and this is the equation of the chord, okay, of PQ. Okay, this is proved here, and now with the base of this chord, and we want to show the 22, okay. See carefully, this is a very important question here, and if the eccentric angle of the extremities of the two chords, so like this is the chord and this is the another chord are given there, okay, for the 22 number questions, okay, whose the four eccentric angle are given there, that is alpha, beta, gamma, delta, and we have to show the tan alpha by 2, tan beta by 2, tan gamma by 2, tan delta by 2 equal to 1, and it is given that this chord is equidistant from center to the where the two chords are intersect to the major axis, means and this chord is intersect to the x-axis, major axis at some, let us assume d comma 0 on this part, on the first quadrant, and on the other side it is intersect at minus d comma 0, and given that the distance are same, means where the chord are intersect to the major axis, both the chord are intersect to the major axis at some point, and that point is degree distance from center. Okay, that's the degree distance from center. Okay, this is the given condition. And let us assume this is a chord. This is a chord. Okay, for 22. For 22. Okay, for 22. See, and follow this chord. Okay, when the eccentric angle be alpha beta, when the eccentric angle, okay, eccentric angle angles are alpha and beta, okay, then the equation of chord when it is given alpha beta and beta are given taken. Okay, so gamma and delta, then the equation of two chord, then the equation of two chords are, so that is x by a cos of alpha plus beta by 2, and this is y by b and sine of alpha, same as, okay, sine of alpha plus beta by 2, and this is cos of alpha minus beta by 2, okay, and x by a cos of, that is the gamma plus delta by 2, and y by b sine of gamma plus delta by 3 is equal to cos of gamma minus delta by 3. This is number 1 and this is number 2. Okay, and again see, from the center it is equidistance where these chords are intersect to the major axis. Okay, where the distance are equidistant from the two chords are intersect to the major axis, like if we intersect at the point d, 0, then it is intersect on the major axis on the right hand side b minus c, 0. Okay, so let us assume by given condition, the two chord intersect with the major axis. Two chords intersect with the major axis at d, 0 and minus d, 0. Again we say why we take the d as the same in the magnitude value. Again we say your chord is intersect to the major axis at a constant distance from origin. Okay, so it means if this is d, then this also are d. So you can take as a d, 0, then their coordinate be at that minus d, 0 here. Okay, so that's why d are same. Okay, and now the one is passing through d, 0 when when one is passing through d, 0, then we get d, 0. So that is d by a. This is d by a cos of alpha plus beta by 2, and this is 0 by b is 0 here, so that is equal to, and cos of alpha minus beta by 2 here. So d by a implies that, so d by a is equal to, we can write here cos of alpha minus beta by 2 into, okay, when 2 is passing through minus d comma 0, then minus d comma 0, this is here, minus d by a, and that is equal to cos of gamma minus delta by 2 by cos of gamma plus delta by 2 here. So this is d minus d by a, and this is d by a. So we can write here that is equal to cos of alpha minus beta by 2 by cos of alpha plus beta by 2 equal to minus cos of gamma minus delta by 2 by cos of gamma plus delta by 2. So we take this as a minus here and apply the component of dividend. Apply the component of dividend. Okay. So this is implies that, and cos of alpha minus beta minus cos of alpha plus beta and by 2 by cos of alpha minus beta by 2 plus cos of alpha plus beta by 2 here, and this is equal to, same on the right hand side, this plus this and this plus this. If we this plus this, then on the right hand side, on the numerator part, this will be minus. Okay, so this plus this, or this minus this, we are doing here this minus this. So this is this minus this means plus. Okay, so cos of this minus this as a plus of cos gamma delta by 2 here again, and cos of minus, okay, see, and this is the, if we simplify this, this is sin alpha by 2 sin beta by 2, and this is cos alpha by 2 cos beta by 2. Also easily we can write tan alpha by 2 and tan beta by 2, and this is here also cot this by this and cot delta by 2 here. If we 1 by tan 1 by 2 we written, then tan alpha by 2 and tan beta by 2 and tan gamma by 2 and tan delta by 2 is equal to 1 here. 2. Okay, this is a very interesting question for this video, and two questions, last two questions, this is 16 and 22 on the SME book. This is very important question for joint IT and icons. Okay, see carefully. Bye.